Hi friends, let's look at some problems wherein you have to use this table of standard angles to do the problems. For example, sine of 0 is 0, sine of 30 is half, sine of 45 is 1 over root 2, sine of 60 is root 3 by 2, and sine of 90 is 1. Cos of 0 is 1, cos of 30 is root 3 by 2, cos of 45 is 1 over root 2, cos of 60 is half, and cos of 90 is 0. And tan of 0 is 0, tan of 30 is 1 over root 3, tan of 45 is 1, tan of 60 is root 3, and tan of 90 is undefined. So this table and these values you always have to remember and write it down while solving such problems. Let's say we have this problem where it says find values of sine 60 into cos 30 plus sine 30 into cos 60. Okay. Second problem is find the value of sine 30 plus tan 45 plus cosec of 60. See, even though you don't know the cosecant of 60 degree, you know that cosecant is 1 upon sine. Okay. So you take cosecant 60, make it 1 upon sine over 1 upon sine of 60 and then substitute that value. Okay. Similarly, you don't know what is secant 30, but you know that secant is 1 upon cos. So you can take the secant 30, write it as 1 upon cos 30 and then substitute the cos 30 value. Right. Here cos 60 is there. Again, cot 45 you don't know, but you know that cot is 1 upon tan. So what you have to do? Substitute 1 upon tan 45 and then substitute the value. Okay. And the third sub problem is 5 cos squared 60 plus 4 secant squared 30. Here also you can replace this by 1 upon cos squared 30 and tan squared 45, sin squared 30 plus cos squared 30. Okay. So this is the problem. To solve the first sub problem, we can say sin 60 cos 30. So sin 60 you can see that it is root 3 by 2. So I have substituted that. Cos 30 is also root 3 by 2. I have substituted that. And sin 30 is half. Cos 60 is also half. So substituted that. So root 3 by 2 into root 3 by 2. Numerator root 3 into root 3 will give you 3. Okay. Denominator 2 into 2 will give you 4. Similarly here numerator 1 into 1 will give you 1 and denominator you will get 4. Now 4 and 4 are in the denominator, so no problems. LCM need not be taken. It is 4 and 3 plus 1 4. 4 by 4 is 1. So the answer for subproblem 1 is 1. Okay. Now for subproblem 2, sin 30 we have substituted half. Okay. Tan 45 we have substituted 1 because from the table as you can see tan of 45 is 1. And as we told you, cosecant 60 we know is 1 upon sin 60. So we have substituted and there is a minus sign here. So minus 1 upon 1 divided by sine of 60. What is sine of 60? Sine of 60 is root 3 by 2. So root 3 by 2 we have substituted here. Okay. For secant 30 we have substituted 1 upon cos of 30. Cos of 30 as you know is root 3 by 2. And cos 60 is half. We have substituted here. Cot 45 is 1 upon tan 45. What is tan 45? Tan 45 is 1. So we have substituted 1 by 1. Okay. Now here you can see that this will half you can write it as is. 1 you can write it as 1 upon 1. 1 upon root 3 by 2 you can write it as 2 by root 3. Okay. Similarly here also you can write it as 2 by root 3. Then you can write this as half as is and this you can write it as 1 upon 1 as is. Now to add these three guys, you have to take an LCM. What is the LCM here? 2 is there, 1 is there, root 3 is there. So 2 root 3 is the LCM. To make the denominator 2 root 3, you have to multiply the denominator and numerator by root 3. Correct? So 1 multiplied by root 3, you will get root 3 here. And to make 2 root 3 as the denominator, you have to multiply both the denominator and numerator by 2 root 3. Okay? So instead of 1, you got a 2 root 3 here. To make root 3 as 2 root 3, you have to multiply it by 2, right? So numerator also you have to multiply it by 2. So 2 2s are 4. You got the 4 here. So LCM is 2 root 3 and the numerator looks like this. Okay. Similarly here also you have got root 3, you got 2, you got a 1. So LCM is 2 root 3. To make root 3 2 root 3, you have to make multiply both the denominator and numerator by 2. So you get 4. And you have 1 by 2 to make it 2 root 3. You have to multiply both the denominator and numerator by root 3. So you got that. And to make 1 2 root 3, you have to multiply the numerator also by 2 root 3. So you got that. So you have 4 plus root 3 plus 2 root 3 and divided by this 2 root 3, which is the LCM. Now because these both are fractions and because this is a division, this 2 root 3 will go up and the whatever rest terms will come down. Okay, so if you look at this numerator, you got root 3 plus 2 root 3, that is 3 root 3's, right? 3 root 3 minus 4 divided by 2 root 3, and when you invert this, 2 root 3 will go up and you will get 3 root 3 plus 4 here. Okay, 3 root 3 plus 4. Okay, so 2 root 3 will cancel off, and 3 root 3 minus 4 divided by 3 root 3 plus 4 will remain. That is the answer. Okay, for this problem we have substituted 5 is as is, cos of 60 is half, right? So half squared we have substituted here. 4 secant 30. Note that though we don't know the secant, we know that secant squared is 1 by cos squared, and 1 by cos squared of 30 we can substitute like this. So 4 divided by 4 into 1 upon cos of 30 is root 3 by 2, root 3 by 2 whole squared. Okay, minus tan squared 45, tan squared 45, tan 45 is 1, so 1 squared we have put, divided by, here you have sin squared theta plus cos squared theta. We know that by trigonometric identity, sin squared theta plus cos squared theta for any theta is 1. So we have put 1 here. Okay, so here when we simplify, you can see that 1 by 2 whole squared will give you 1 by 4. So 5 into 1 by 4. Here you'll get 4 into 1 divided by, what is the square root of root 3? It is 3. What is the square of 2? It is 4. So you'll get 3 by 4 here, and minus 1, that is equal to 5 by 4. This 4 will go up, 3 will remain, 16 by 3 minus 1 by 1. Okay, so what is the LCM here? We have a 4 here, we have a 3 here, we have a 1 here. So 12 is the LCM. Okay, so to make this 12, we have to multiply both the denominator and numerator by 3. So 5 3s are 15, and to make this 12, we have to multiply both the numerator and denominator by 4. So 16 4s are 64, and here 12, right? So we have put 12 here, 12 here. So since there is a minus sign here, it's minus 12. Okay, so 15 minus 12 is 3, right? 3 plus 64 is 67. 67 by 12 is the answer. Okay, so the next problem says 2 tan 30 divided by 1 plus tan square 30 equal to which of these values? Is it equal to sin? Option A is sin 60, option B is cos 60, option C is tan 60, or option D is sin 30. Which of these is equal to? So first we need to find what is 2 tan 30 divided by 1 plus tan square 30. To substitute, we'll get 2 times tan 30. So tan 30, as you can see in this table, is 1 upon root 3. Okay, so coming back here, 2 into 1 upon root 3 divided by, you have 1 plus tan square 30, that is 1 plus 1 upon root 3 whole squared. Okay, so 2 by into root 3 will become 2 into root 3. 1 upon root 3 whole squared will become 1 upon 3. Okay, so this will become 2 divided by root 3, whole thing divided by 3 is the LCM. 3 will go up also to the numerator. So 3 plus 1 divided by 3. So this is 4 by 3, and because there is a division here and this is a fraction, here we get 2 by 3, and multiplied by this 3 will go up and the 4 will remain down. Okay, and you can cancel 2 2s are 4, and root 3 cancels, root 3 remains. So finally what you will be left with is root 3 by 2. Okay, from the table you can see that root 3 by 2 is nothing but sine of 60, isn't it? So the option A is correct. Since we got the root 3 by 2, that is actually sine 60. So option A is correct. Okay, let's look at a few more such problems. So we are saying sine 2a is equal to 2 times sine a is true when the angle is 0, when the angle is 30, when the angle is 45, when the angle is 60. When is this true? So when the angle is 0, what is your LHS left hand side of the equation? Sine 2a. Okay, when the angle is 0, sine 2a is sine 2 multiplied by 0. That is 2 multiplied by 0 is 0. That is sine 0, right? Sine 0 is 0. We know that. RHS is 2 times sine a. That is 2 times sine of 0. Sine of 0 is again 0. So 2 times 0 is also 0. Okay. So since LHS is equal to RHS, option A is correct. Sine 2a is equal to 2 times sine a when angle A is 0. Okay. The next question says tan a plus b is equal to root 3 and tan a minus b is equal to 1 over root 3. What is the value of A and what is the value of B. Okay, when tan A plus B is equal to root 3, from the table if you see, root 3 means that angle should be 60 degree, correct? So here A plus B is equal to 60 degree. Okay, similarly when the table tan A minus B is equal to 1 over root 3, which is given, which means A minus B is equal to 30 degrees. If you look at the table, the tan becomes 1 upon root 3 when angle is 30 degrees. So A plus B is 60, A minus B is 30. Now if we add both the LHSs and RHSs, if you add the LHS, you'll get A plus B plus A minus B, correct? And same thing you have to do with RHS, 60 plus 30, correct? Now B minus B will cancel out, 2A will remain, 60 plus 30, 90 will remain, which means if you send the 2 to the denominator, A is equal to 90 by 2, which is 45. Okay, so we got the A value as 45. Now you can substitute in one of these equations the value of A. Okay, so 45 plus B is equal to 60. Okay, so to get B, you send the 45 that side of the equal to sign, it will become minus. So B is equal to 60 minus 45, that is 15. Okay, so A is 45 and B is 15. Okay, next question says express ratios of cos A, tan A, secant A in terms of sin A. Okay, so this is you have to do this using trigonometric identities, because they are saying what is cos A in terms of sin A, what is tan A in terms of sin A, and what is secant A in terms of sin A. Okay, so to express cos A in terms of sin A, we can use cos squared A plus sin squared A equal to 1. We know that identity. So cos squared A is equal to 1 minus sin squared A, or cos A is equal to square root of 1 minus sin squared A. So in this way we have expressed cos A in terms of sin A. Okay, what is tan A in terms of sin A? Tan A is sin A by cos A, but cos A itself we have expressed in terms of sin here. So we can substitute and we can say that tan A is nothing but sin A divided by square root of 1 minus sin squared A. Okay, what is secant A? We know that secant A is 1 upon cos A, right? But what is cos A? Cos A is root of 1 minus sin squared A. So secant A is 1 upon square root of 1 minus sin squared A. So using this technique, we have expressed tan A, secant A, cos A, everyone in terms of sin A. Okay. Next question says, prove that secant A into 1 minus sin A plus secant A plus tan A equal to 1. See, remember, whenever you want to prove LHS is equal to RHS, one thing you should always do is express everything in terms of sine and cos. I repeat, whenever you want to prove anything, LHS is equal to RHS, please express everything, all the trigonometric quantities in terms of sine and cos. So I have done the same thing. So you take this secant A, what is it in terms of cos? It is 1 over cos, okay, multiplied by 1 minus sin A. This is already in terms of sine, so we don't need to bother about it. Multiplied by, what is secant A again? 1 over cos, right? What is tan A? It is sine by cos. So note, to prove that LHS is equal to RHS, it is always convenient to express every trigonometric value as sine and cos. Okay, so here what is happening is, this is multiplying the bracket. So bracket 1 minus sin A by cos A is coming, multiplied by, here the denominator is same. You can see it is cos A cos A. So you can take the denominator and 1 plus sin A will be the numerator. Okay, now 1 minus sin A into 1 plus sin A, what does this look like? This looks like A plus B into A minus B, right? Which is A squared minus B squared. Instead of A we have 1 and instead of B we have sin, right? So A plus B into A minus B, A squared minus B squared, we can write it as 1 minus sin squared A. And what is this in denominator? Cos into cos, you will get cos squared A. Okay, but using this cos squared theta plus sin squared theta is equal to 1 minus sin squared theta. So if you take sin squared theta to the other side, you will get cos squared theta, isn't it? So here 1 minus sin squared A, you will get cos squared A. Denominator is also cos squared A. So cos squared A cancel, you will get 1. Okay, so we have proved that the LHS is equal to the RHS, which is nothing but 1.